Welcome students. आओ एक बार फिर ਅਸੀਂ ਅੱਜ ਇੰਟੀਗਰਲ ਇਕੁਏਸ਼ਨ ਦੇ ਨੈਕਸਟ ਫਾਰਮ ਨੂੰ ਦੇਖੀਏ। ਇਸ ਫਾਰਮ ਦੇ ਵਿੱਚ ਅਸੀਂ ਜਿਹੜਾ ਹੈ ਉਹ ਕਨਵਰਟ ਕਰਾਂਗੇ ਇਹ ਬਾਉਂਡਰੀ ਵੈਲਿਊ ਪ੍ਰੋਬਲਮ ਇਨਟੂ ਐਨ ਇੰਟੀਗਰਲ ਇਕੁਏਸ਼ਨ। So last two lecture we convert differential equation with initial value problem to integral equation, but this lecture is converting a boundary value problem. So this is a boundary value problem into an integral equation. So myself is Dr. Amanpreet Singh, PG Department of Mathematics, Khalsa College Patiala, and the method which required to solve this type of to converting boundary value problem into an integral equation is again the same, that is conversion of multiple integral into single integral. So here we have multiple integral a to x yt dt raised to the power n is equal to a to x, this is single integral x minus t raised to the power n minus 1 over n minus 1 factorial into yt dt. So let's see how we solve this boundary value problem definition. When an ordinary differential equation is to be solved under condition involving dependent variable and its derivative at two different, students be very careful, at two different values of independent variable, then the problem under this consideration is said to be boundary value problem. X is equal to a and x is equal to b. So independent variable is x, and here x is equal to a and x is equal to b. The value is different. So dependent variable is y, y is equal to y, and yb is equal to y2. Is a boundary value problem. Note that here different values x is equal to a and x is equal to b of independent variable x are involved. So let's see how we solve this type of question. So first example is reduce the following boundary value problem into an integral equation where boundary value problem is d2y by dx2 plus lambda y is equal to 0 with y0 is equal to 0 and yl is equal to 0. So student be very careful here, x is equal to a and x is equal to l are the boundary values. So we want to solve this given this equation, and we change y double dash is equal to minus lambda into yx. Now the method remains same which we have discussed earlier, that integration both sides with respect to x from 0 to x, and we got 0 to x y double dash x dx is equal to minus lambda 0 to x yx dx. So this integral y double dash x becomes y dash x from 0 to x minus lambda 0 to x yx dx. And by substituting value we got y dash x minus y dash 0 is equal to minus lambda 0 to x yx dx. This is a fundamental theorem of integral calculus. But y dash 0 is not given, so I take y dash 0 as c, a constant. When we replace value, y dash c is equal to c this side minus and this side we got plus, c minus lambda 0 to x yx dx. Again integration both sides with respect to x from 0 to x we got 0 to x y dash x dx is equal to c into 0 to x dx minus lambda from 0 to x yx dx. Here this is a multiple integral now, and this y dash x becomes yx 0 to x c into x and minus lambda, and this is we change variable x with t. So now what we got, yx minus y0 is equal to cx minus lambda, and this is multiple integral convert into single integral by the method which is written in the first slide. So x minus t raised to the power 1 over 1 factorial yt dt. Now y0 is given, that is 0, so I put y0 is equal to 0, and the final result is yx is equal to cx minus lambda 0 to x yt x minus t yt dt. But the constant, unknown constant which we take here, c is not known till time. So how we find c? Putting x is equal to l here. So yl is equal to cl minus lambda 0 to L x minus, that is L minus t yt dt. So we find this C, and how we find C? Because YL is equal to 0, it's given YL is equal to 0. So CL is equal to lambda into, yes, CL is equal to lambda into 0 to L minus t yt, and when we divide by L with CL means C is equal to lambda y. So we find the value of C every time. In every question we find the value of C. So yx is equal to, and after substituting this value yx here, yx, just see, this is yx is equal to cx minus lambda 0 to x minus t yt. Here we substitute this value. Yx is equal to lambda yl x 0 to L minus t yt dt minus lambda 0 to x minus t yt dt. Now what happened? Now we shift this value inside, and 0 to L, and here it is 0 to x. So 0 to L is split into two parts. First part is 0 to x, and second part is x to L. So 0 to x and x to L. 0 to x here, 0 to x here. So we subtract these two. Yx is equal to, take lambda common. This is x into L minus t by L minus x minus t yt dt plus lambda into x to L x L minus t by L yt dt. I take L as LCM. When I take L as LCM and simplify it, I got this result. Yx is equal to lambda 0 to x. This is t into L minus x by L yt dt plus x to L x into L minus t by L into yt dt. So I take this as a kernel xt, and what is kernel? Kernel we define as here kxt. Kxt is equal to, yes, t by L into L minus x, t by L into L minus x when t varies from 0 to x, and kernel is equal to x by L into L minus t when t varies from x to L. This is our first differential equation which we convert into integral equation. This is this is boundary value problem. So now come to another question. This is a transform d2y upon dx2 plus xy is equal to 1, where y0 is equal to y1 is equal to 0 into an integral equation. Also recover the boundary value problems you obtained. So given that y double dash x plus x into yx is equal to 1. So I shift this x into yx into right hand side. So y double dash x, integration both sides with respect to x. From 0 to x we have 0 to x y double dash x dx, 0 to x 1 into dx, 0 to x x into yx dx. So here y double dash becomes y dash x, and 0 to x by fundamental theorem 1 integration of 1 is x and remaining as such. Fundamental theorem says y dash x minus y dash 0 is equal to x minus 0 to x x y dx, yx dx. But y dash 0 is equal to c. Let y dash 0 is equal to c. In previous question we also take this as c. So y dash x is equal to c plus x from minus 0 to x x y x dx. So again we integrate with respect to x. From 0 to x we got 0 to x y dash x dx, 0 to x c plus x into dx minus 0 to x x into yx dx square. So we convert this, y dash x means yx from 0 to x, and c into x plus 1 x square by 2 from 0 to x minus 0 to x. This is x, convert now into t yt dt square. So now we apply the formula which is written in the first slide. So multiple integral change into single integral. So yx minus y0 is equal to cx plus 1 by 2 x square minus 0 to x x minus t raised to the power 1 over 1 factorial into t yt dt. So y0 is given and y0 is 0. So yx is equal to cx plus 1 by 2 x square minus 0 to x x minus t, t, yt and dt. So students, up to here the question remains same, but now we want to find the value of c. So how we find the value of c? Put x is equal to 1. So y1 is equal to c plus 1 by 2, 0 minus 0 to 1, 1 minus t, yt, dt. And y1 is equal to 1. So I got value of c is equal to, yes, 1 minus 1 by 2, 1 by 2, plus 0 to 1, 1 minus t, t, yt, dt. So all these values we put in the yx. So yx is equal to, here we put yx is equal to x into c. So c is this, plus 1 by 2 x square as such, and this part as such. So converting this, just see 0 to 1 and 0 to x. So I change this 0 to 1 by splitting it into 0 to x and x to 1, as we done in the previous question, 0 to x and x to 1. So 0 to x and 0 to x, we combine these two. Then we combine these two, 0 to x, xt into yt, 1 minus t, and here minus t into x minus t, yt, dt. So t into yt we take common. This is x minus xt minus t x and minus t square. So I take t as common, so x minus t as such. So and remaining part as such. So when we see 1 by 2x into 1 plus x plus 0 to x t square, 1 minus x cancel, so t square 1 minus x yt, and 1 to x to 1 xt, 1 minus t yt dt. So I take it as kxt. So this is kxt, where kxt is written as we see in the earlier question. Kxt is equal to t square 1 minus x when t vary from 0 to x, and xt into 1 minus t when t varies from, yes, x to 1, that is t is greater than x. So this is all about this. To recover the boundary value, this is all about the integral equation. To recover the boundary value problem from the integral equation, we just differentiate this. So yx is equal to this, and differentiate both sides with respect to x using Leibniz rule. So student, be very careful. Here we use Leibniz rule. And what is Leibniz rule? Y dash x. This one is the simple. So derivative under the integral sign. When we see integral sign differentiate with respect to x, this becomes minus t yt dt plus, and this is x square. Replace t with x square 1 minus x yx, and derivative x with respect to x, and replace t with 0, we got 0, plus here also replace t with x with t and dt, and again plus x into, replace 1 first with 1 and when next with x. So this is a Leibniz sign, and we got this results. After this, we again differentiate both sides with respect to x using Leibniz rule. And what is Leibniz rule? Again, y double dash. So differentiating this, we got 1, 0 to x. This is partial derivative with respect to x. There is no x, plus converting t with x into yx, derivative with respect to x, and when we put 0. Similarly here, so partial derivative with respect to x, this is 1 minus t, convert with 1 minus 1 yt, d1 by dx minus x, now convert t with x minus x square yx, and derivative of this. Simplify, we got 1 and this is 0, so this is x square yx, dx by dx 1, this becomes 0, this becomes 0, this becomes 1 minus 1 0, and this is x minus x square yx dx. So on simplification, just yx take common, on simplification we got this, and this is nothing else, this is the given differential equation. So come to the example exercise. Students, this is very simple question as we discussed earlier. So if you find any difficulty, you can discuss with me anytime. So I can solve all the question for you. Thank you.